please.
Thank you very much, Thomas. And yes, I'm very proud because AI is in everybody's mouth these days. And to show here an experience of more than 25 years using these technologies, I would like to show you in my presentation. And I give this presentation also this title, Process Knowledge that Creates Instruments for AI Control. If you understand, process knowledge is a human gift, and engineers' knowledge must be considered also in today's control concepts. Working only with mathematical, statistical models, process models, makes, from our experience, and this is also quite long, 25 years, no sense. The knowledge of the single operator, of the single process experts in the cement plant, of the specific mill and kiln must be considered, and we do that. However, control systems are depending on the information they get. So instrumentation plays a major role. We as KIMA Process Control, we become famous by developing the electronic ear smart fill for our high-level control systems for mills. That was the first step. 900 of these ball mills are equipped with this electronic ears worldwide. And I would like to show you that huge companies like Holcim, Heidelberg Cement, and others knock on the door of KIMA to ask the research and development company to develop new sensors. And this is my introduction today. With our sensors and with our automated control of mills and kilns, ladies and gentlemen, carbon footprint, we have saved 5.6 million tons since 1996 to 2022. And you can imagine we are very proud about that. Each day, 730 tons of CO2 are just saved by optimized automated control of mills and kilns. Our products to do that are a high sophisticated cooling of your kiln shell, not with air, which is high power consuming, but with a water mist. A product which is called Kiln Cooler, and I have given plenty of presentations that during conferences in the world. The SmartFill electronic ear for ball mills, as I told you, will be part at the end of the presentation. Gas temp is one product which is relative new. This product was developed on demand of Holcim in Holderbank, Switzerland. They asked us to find an alternative for thermocouples and for pitot tube and delta P measurements, because these measurement principles are too slowly and too sensitive and inaccurate for the cement control. So finally, of course, there's the software, Smart Control. We have Smart Control for the mills and Smart Control for the kilns with Mill Master and Kiln Master. I would like to announce today already to everybody that these old names which we have founded together with Holcim, we were a technology partner of Holcim when we designed this software, these names will be changed to make clear there is a complete different product which we as KIMA sell today to the Mill Master and Kiln Master from Holcim. So look into the news within the next couple of days. There is some name exchange coming. However, AI, artificial intelligence. As I introduced already, we have a couple of technologies behind AI. There's model predictive control, there's nonlinear model predictive control, and fuzzy logics. And I thank also Thomas, again, Armstrong. He has said in the introduction, 2001, I founded the company Powitech Intelligent Technologies. Ladies and gentlemen, in 2002, we controlled the first kiln with nonlinear model predictive control in Powitech Intelligent Technologies. So a huge knowledge using these technologies are behind us. And today I'm very proud to speak about the latest, the Kiln Master, which is the future of kiln operation for autonomous control. And here I want to first, in the first moment, make a big difference between that what is happening today, general, what is state of the art, and that what we do in future. You see that energy flows from clinker cooler to kiln, and from kiln to preheater tower are operated in separate control loops. So we speak about 3 control loops. The problem is, if you control single loops, they can start skating. Here will be a shift inactive, and you will see that if you go to your plant today, tomorrow, and look into your operation, you will always see these skatings, these movements up and down. This is not quality. This so-called coefficients of variance is too high. This is why we work in a new concept with an entire control loop for all 3 modules in one controller. And this is only possible when you have, think about the title of my presentation, adequate instrumentation. And this instrumentation means we measure today continuous the gas flow and the temperature punctual-wise with a precision of plus minus 1%. Yes, gas flow plus minus 1%. I come to this a little bit later. Now, when you measure so precisely the gas flows and the process, you can see immediately when there is, for instance, a change in the heat value of your fuels. If you start with alternative fuels, you need an information where is the change in the heating, where's the change in the energy input, and which effect does this have into the entire process to avoid the skating effects. Now, here we can see now we have the preheater, we have the kiln, and we have the cooler. So all these 3 modules are in one big controller. And now we measure the gases. We measure tertiary air, we measure secondary air, we measure the downcomer, which is here, the exhaust gas, and we measure also the cooler exit. Now you can imagine that this is a very precise analyzation now of enthalpy flow, energy flow. This is new. And this is with this precision of this sensors, these instruments, giving you opportunities to increase productions of kilns between 5 and 10%. With this reduction of coefficients of variance and this precise out control now, we see if the kiln gets less fuel and energy from the main burner or from the preheater burner. Now, to measure this, and this is again the content today, we designed gas temp and gas temp flow, an acoustic measurement which is measuring gas flows and temperature in very high dust-containing gases, and also with changing dust content and with high temperatures up to 1,500 degrees. I would like to confront you with this measurement principle a little bit. Look, thermocouples are from the speed very, very slowly, because the housing itself of this sensor must be heated up first until the measurement itself can give out a change to the control system. Delay time. We come to that later. The other thing is, it's not a non-contact system. It's a contact system. So if you put such, let me call it finger inside this combustion room, you will have an effect of the infrared radiation. And this infrared radiation from clinker and from flame does not allow you anymore to measure the pure gas temperature. An acoustic measurement principle is completely different. And the gas flow measurement, also short explained, if you work with pitot tubes, they are very sensitive. You see that, by the way, these are these nozzles which you see on an aircraft, on the cockpit outside. There is measured, and also on the wings, there are always these pitot tubes to measure the pressure. If you use that, it's very sensitive in view of dust and maintenance, of course. Similar if you use delta P. If you use a delta P, you know exactly that you have to change from one diameter to another diameter and to another diameter again. This means you slow down your gas flows. No need with the acoustic measurement principle, which works as follows. We are working with so-called horns and transmitters, so we send an acoustic sound produced by a compressed air flush, similar to an air cannon, an air shock cannon, similar. And we send this sound through the entire duct, so a cross-section, full cross-section. we have here a microphone and we have here a microphone. And the time this sound needs is 100% related to the temperature. We see here the first signal, remember here, that is the first microphone, and the second microphone on the opposite side of the duct. And this delta T, which we measure time, not temperature. This time we can now translate into temperature. In electronic measurement, nothing can be more precise measured than time. And this is the big advantage. If one of the sensors falls out, you can change it, but the distance remains. So the system should be not calibrated anymore. The system is parameterized at the beginning and then running forever. Very nice technology, and this technology has a big advantage, the speed. Let us speak about the speed of this measurement. You see here a calciner exit. Calciner exit is of course necessary to measure the temperature so that you are having a good outburn. Today's control is happening with these thermocouples, and you see already the offset of the thermocouple is more than 100 degrees. Infrared radiation from the flame. Now, the acoustic pyrometer sees this increase of a temperature 50 seconds earlier. 50 seconds is hell of time in combustion, you will agree. But more interesting is, today you control on these thermocouples, and when the thermocouples show there is a peak, the acoustic pyrometer says, this is already history. Interesting for process optimization, also the secondary air temperature, the heat recuperation from the clinker cooler into the kiln. Here you are using also usually thermocouples, and these thermocouples, which are installed usually here on the kiln hood, have a big influence from the main burner's flame and from the running clinker. So when we measure a cross-section over the kiln hood now, we are independent from this heat radiation. So again, this offset shows us that the thermocouple is complete on the wrong way. And we are so fast that we even see when the shock blowers on the static grid of your clinker cooler are avoiding the snowman, we see boof, boof, that the temperature has drops. Nothing to compensate, nothing to control, just to show you how fast this temperature measurement is. The principle of the flow measurement is very similar. We use the same sensor, but not one and two microphones. We have a third microphone. And this microphone then is used to measure the time between a distance, a defined distance. And you, as technicians, you know, defined distance with variation time, speed. Seconds per meter, seconds per centimeter. And this is what we do. We measure the time and we can give you the exact gas flow. Again, we measure time. Not gas flow, not pressure or something like that. Contactless. This makes it possible to measure, for instance, to measure the downcomer air volume with a precision of plus minus 1%. The success of this measurement is phenomenal. We have installations in the meantime in Votorantim, in Heidelberg Cement, in Holcim, in Buzi, nearly everywhere, and I hope we come soon also here in this region. You see here the fast measurement, a 72 hours plot of the temperature and of the nominalized flow in the downcomer and here also in the tertiary air. I jump a little bit forward to show you what KIMA, because the time runs, so that we can see also what such software and instrumentation can reach. In YTL, Malaysia, Kantan plant, the mill master with electronic ear smart fill has reached on the cement mill number 5 and 6 with full autonomous operation. That means the operator steps back, like in a Tesla car, go from here to there. Tesla is a bad copy. Autonomous operation, let me say. So we drive the mill or the kiln autonomous, so the operator can do everything else. In this moment, 6% production increase, and I would like to show you how this production increase is settled. You see that here, very rudimentary, the mill feed was adjusted by manual operation without millmaster. And the millmaster now is automatically adjusting the feed however it is necessary. Autonomous, fast, quick, reducing the coefficient of variance, improving the product quality. And if you're interested in that specific, I would like to show that later on, maybe on my booth, which I have in front of the presentation hall here. Certified this reference results also in Saurashtra cement of the Mehta Group in India. We have reached on cement mill number 1 phenomenal 12% production increase. Ladies and gentlemen, 12% production increase means a return of invest of this system of 1.5 months. Al Safwa Cement, my friends there said, Dirk, this is a cash machine. We want to equip more of our cement mills because in a short time we are able to produce the same amount of cement instead of 8 hours in 6 hours. Good example, I think. So here also nice to see, without millmaster, the more or less digital adjustment by manual or by PID controller, or depending on the, as everybody drives usually, bucket elevator current. And here the millmaster using the smart fill signals. And smart fill is the electronic ear on ball mills equipped on 900 mills globally. Huge success. In the meantime, the company Magoto is using the system in the minerals industry and relabel it as Magosense, powered by KIMA. The advantage of this system is here again in these slides, easy to see. The manual operation does not work. If you stop with your activity as operator, and the operators have to do something else than only to look at the fill levels. Fill level 1, fill level 2 are this green and blue line. Now you see that the mill becomes empty. Do you believe that the same quality of cement is produced here and here? No. So this is why we are using consequent the smart fill signals to adjust the fresh feed and the separator speed for a full autonomous mill control. And that was it already today. I hope I can see you and talk with you later on my booth. It's just outside, booth number 5. Thank you very much for your